For some weird reason, our today's Zoom class meeting was not recorded on Zoom or was not processed, so I'm recording this video to help us to remember what we went over in today's meeting. The first question was, I'm having trouble determining when to reject or fail to reject the null hypothesis. Before we answer this question, let's go over 3 types of testing that we can perform. Test can be left-tailed, right-tailed, or two-tailed. How do we know which sign to pick, which side, the left, the right, or 2 sides? That will be determined by the alternative hypothesis. If alternative hypothesis, if H1 is less than, then the tail will be left-tailed. And your alpha will be located, and your alpha and p-values will be located on the left. If alternative hypothesis has greater than sign, points to the right, then we're dealing with the right-tail test. And your alpha will be located on the right side. Your alpha and your p-value is located on the right of the density curve. If the alternative hypothesis has not equal sign, that means your alpha is split in 2 areas and your p-values are in 2 areas. Therefore, for example, we are doing a test with alpha, our critical region 0.05 or 5%. That means our 0.05 will be split in 2 regions. 0.05 on one side and 0.025, 2.5% on one side and 2.5% on the other side. We'll have to divide this region into 2. How do we know when to reject or fail the null hypothesis? Now let's answer this question. We reject null hypothesis if p-value is less or equal to alpha. If our p-value, our probability is less than the alpha, the critical region that we're testing it against, that means the probability of something happening by chance is lower than our alpha, usually 5% or 1% or 2%. The most common is 0.05 and 0.01. We fail to reject null hypothesis if p-value is greater than alpha. That means that our p-value will be past the critical region. The same with the test statistic. Here in the green, I marked critical values, the values that separate the critical region from non-critical region. In the left-tail test, the critical value is negative. In the right-tail test, the critical value is on the right side, so it's going to be positive. In the two-tail test, the critical value is located in the left and on the right. It's going to have plus or minus sign. What are the critical values? The critical value and the test statistic. For the population proportion, we use Z. For the population mean, we use mu, not mu, for T. We use T statistic. For the population standard deviation, we use chi-square distribution. To find Z statistic, we can use table A2 Z values. To find T statistic, we can use table A3 with the T distribution. To find chi-square statistic, we use table A4 with the chi-square distribution. Now we learned that to reject the null hypothesis, p-value must be less or equal than alpha. P-value would be here, smaller than the critical region. The Z statistic uses the same principle. If the z-statistic is in the critical region, then we reject the null hypothesis. If the test statistic, your z-score or t-score or chi-square score is not in the critical region, then we fail to reject the null hypothesis. Next question was PWQ had a question where it gives you a test statistic z equal 0.85 and a claim p is greater than 0.9. How can we find p-value with just this info? It also says to use a significance level of 0.10. This extra piece of information is probably for the next part of the question. So let's answer the question. How do we find the p-value with just this info? We are given the z-statistic. Remember, we always want to draw a picture just to help us visualize. So we're going to draw a picture of a normal distribution. And the z-statistic is 0.85. The z-statistic is positive. It's right here. It's equal to 0.85. Therefore, the test is, let's see, this claim will tell us which side the claim is. Although we can see it from here that it's probably going to be the right tail. P is greater than. The greater than points to the right. Therefore, our p values will be located to the right of our z statistic. Let's first use the table A2 z distribution, and then we will look how to find the p values in the calculator, in the graphing calculator. So our z statistic, remember, it was 0.85. We are now looking at here's our z score, 0.885. We get to the 5. Here we go. 0.8023. Now remember that the table will give us the areas to the left of the z-statistic. And we need the area to the right of the z-statistic. So we will need to subtract 1 minus 0.8023. It is equal to 7791. 1977, 19.77%. Our p-value, the probability to the right of our z-statistic of 0.85 is 0.1977, 19.77%. Now, if you forgot to convert it, if you forgot to subtract from 1, and you get the score for this little piece of 0.823, think about it. 0.823 is 80%. This does not look like 80%. The whole area under the density curve is 100%. This does not look like almost all of it, right? This side looks like 80%. This side would be 1 minus 0.1977. Now let's look at how to find p-values using the graphing calculator. In the graphing calculator, we're going to go to second vars to get to distribution. Then we scroll down to normal CDF. Then we want to identify the lower and the upper limits. The lower limit in this case, because we're looking to for the area to the right of our z statistic, then our z-statistics 0.85 will be the lower limit, and the upper limit will be positive infinity, which we will enter it as 0.09999. Mu is 0 for the standard distribution. For the normal distribution, standard deviation is 1. Scroll down, click paste. If you have a TI-83 calculator, that this is how your screen probably will look like. You will need to enter in the parentheses the left value, the right value, then mean 0, and standard deviation 1. Click enter again. Here's our p-value, 0.19766, and we rounded to 4 decimal places. Depending on what the program is asking, if the program is asking you to round to 3 decimal places, then you round this value and the value that you found from the distribution table to 3 decimal places.